Alright, time for our last major type of metathesis reaction, which are the gas-forming reactions. On pages 50 through 52, essentially, of your Ultimate Equations Handbook, there's a lot more information on these that probably would be worth looking at. There are 4 essential types of gas-forming reactions, and these are things that just generally produce different kinds of gases. The first one is that any sulfide salt reacting with an acid produces a hydrogen sulfide gas. And so what that looks like is that kind of looks something like XS, or you could call it metal S, so metal salt, plus some kind of acid, HA, that's acid with the I on there, and that will produce H2S gas and some kind of a salt, so XA. You don't see those too often, but you still need to know that they're there. The next one we see a lot, the carbonates and bicarbonates. Anytime that you have a carbonate reacting with an acid, it is always going to produce CO2. And the reason that that happens is because initially it forms carbonic acid, which is super unstable, so then it decomposes along the way. So we'll call this MCO3, some kind of carbonate, plus acid again. And it has an intermediate step. What it essentially does is it creates carbonic acid initially, and then what happens with that carbonic acid is it splits apart into 2 pieces. It splits apart into CO2 and water. And then the other product of that, what we have left, is going to be M and A again, so some kind of salt. Alright, our third type of gas-forming reactions are going to be the sulfite salts with the acids. Notice a lot of these are reacting with acids. So anytime you have a sulfite salt, so that would be MSO3 of some kind, plus the acid, it's going to form sulfur dioxide gas. So SO2, and that leaves us with some hydrogen, another oxygen, so it's also going to form water, and it's also going to form a salt. Now these are unbalanced, these are just general reactions so that you can get the idea of what's happening. And then our final type are the ammonium salts and hydroxides. So this is the only case where you're working with a base. If you have an ammonium salt, so NH4, I'm going to call it, well, what should I call it? I'll call it X, because we can't call it nonmetal, because then that would look like something else. Plus any strong soluble base, so some metal hydroxide, forms ammonia gas. And again, this is kind of a precursor step. What it really forms is ammonium hydroxide, which is then relatively unstable and will turn itself into NH3 and water. And then of course we have again some kind of a salt, some kind of MX salt. Alright, I noticed it got real blurry when I got onto the black stuff a couple slides ago, so we'll try this. For exercise 6, write the balanced and molecular... Okay, going on with our gas-forming reactions, we're looking at exercise 6. We want to write the balanced molecular and net ionic equation for the reaction of sodium carbonate with nitric acid. So if we look at the sodium carbonate first, that's Na, which is +1, with carbonate, CO3, which is a -2, so Na2CO3, that's aqueous. Nitric acid comes from the nitrate ion, so that's HNO3, also aqueous. If we just kind of treat this like a double replacement reaction, we're pairing hydrogen with carbonate, which is going to give us H2CO3, to balance out our charges, and sodium nitrate. All right, now I need to balance this thing out. So I need a 2 in front of the sodium nitrate and a 2 in front of the nitric acid. What I need to recognize at this point is that I've got carbonic acid present here, so that really is going to decompose itself into CO2 and H2O. So the complete balanced molecular equation would actually be Na2CO3 plus 2HNO3 plus H2O liquid plus CO2 gas plus 2 sodium nitrate, which is aqueous. All right, to get our net ionic equation, we first need to go ahead and get a total ionic equation. So I'm going to split up everything I can. That's going to give me 2Na plus a carbonate. Nitric acid is dissociated as well. 2H plus and 2NO3 minus. Now water and CO2, those are liquid and gas, so those stay as they are. H2O is liquid. CO2 is gas. Sodium nitrate can be split because it's also aqueous. So 2Na plus and 2NO3 minus. Kind of ran out of space there, sorry. Now I need to go back through and take out the spectators. So if we start over here with sodium, that is indeed a spectator. Carbonate and hydrogen are part of the CO2 in the water, so we have to leave those. And then nitrate can be removed as well. So then our net ionic equation, 2H plus CO3 minus 2 yields H2O liquid plus CO2 gas. So that was kind of a combination of acid, base, and gas forming.